Alright, today these are notes 7D. This is 8.4 in the textbook, multiply and divide rational expressions. You will be taking notes on your own paper. Alright, so let's begin. Alright, first of all, write down the following rules. So when you multiply or divide rational expression, rule number 1, check to see if you can factor out anything. You're going to factor everything. Step number 2, remember only like binomials can cancel out. Rule number 3, if dividing, don't forget to flip and switch what is after the division sign. Alright, let's add another rule to this. Remember, when you multiply or divide rational expressions, you don't need a common denominator. Alright, here's our first example. Write down your example. If you need more time, pause the video. Alright, here's an example. These are monomials because there's no addition or subtraction in this problem. So basically this is a Unit 6 problem. So let's combine the numerators. So 14 times 2 is 28. A to the 2 plus 2 is 4. B to the 4 plus 2 is 6. On the denominator, 2 times 7 is 14. A to the third B. So these are properties of exponents. So let's simplify. 28 over 14 reduces to 2. Subtract our exponents. So 4 minus 3 is a to the first. And 6 minus 1 is b to the fifth. So I don't need my fraction bar anymore. Here's my final answer. Alright, when we're doing these, the assumption is that none of the denominators are 0. So a cannot equal 0 and b cannot equal 0. So that's an assumption that you go in, assuming, because we can't divide by 0. Alright, let's look at one that's more like what's in Unit 7 here. First of all, let's talk about this idea of what it means to be a like binomial. So warning, only like binomials can cancel out. Alright, look at this big math no-no in the first one. So we have x plus 3 over x plus 2. It's mathematically incorrect to cross out those x's and get 3/2. It doesn't work mathematically. Let's try it with numbers. Let's go 4 plus 3 over 4 plus 2. So we know that's going to be 7 over 6. Alright, let's try to do this math no-no and show you why it's wrong. Alright, your math no-no. So I got 4 plus 3 over 4 plus 2. Alright, if you try to cancel out the 4's here, you're going to end up with 3 over 2. Well, 3/2 doesn't equal 7/6. So you see it doesn't work with a number, therefore it's not going to work with an x. So let's look at a math yes, something that does work. So once you have your factors, all right, you treat this as a single factor. They're connected together. They cannot be separated. So here if we have x plus 3 times x plus 2 over x plus 2, x plus 2 over x plus 2 is equal to 1, so that's why it divides out. It's a multiplicative identity. Therefore, it leaves you with x plus 3. So please watch out for that math no-no, because it will never get you the right answer. Okay, so let's look at another problem. Alright, take a moment, write this down. Those are 2's. It's 5x squared, look kind of like z's. Alright, step number 1. We're going to factor everything. Factor everything that can be factored. So let's look at our first numerator. I'm going to factor out a 5x. So factor out a 5x. That leaves me with x minus 6 over. Alright, let's look at the denominator of that first fraction. It's not in standard form. So in order to be able to factor it, it needs to be in standard form. So let's rewrite it in standard form. Now we're going to factor out a negative 6, which leaves you with x minus 7. All right, let's do the same thing to the second fraction. So let's factor x squared minus 8x plus 7. So it multiplies to give you 7 and adds to give you negative 8. So x minus 7, x minus 1. All right, let's factor that second denominator. X squared minus 7x plus 6. So it multiplies to give you 6, but adds to give you negative 7. So x minus 6, x minus 1. Now, since we've got this all to be multiplication, all right, I can start canceling out like binomials. So I'm going to regroup them so like binomials are over top of each other. So I'm going to rewrite this as 5x, fraction bar, all right, matching up the like stuff over negative 6, coefficient over coefficient. So I've got x minus 6 over x minus 6. I've got x minus 7 over x minus 7. And finally, I've got x minus 1 over x minus 1. I'm just rewriting it to show you why they're going away. You're dividing, right? So this x minus 6 over x minus 6 is 1. Multiplying by 1 is an identity. X minus 7 over x minus 7 is 1. And finally, x minus 1 over x minus 1 is 1. So therefore, our final answer is negative 5x over 6. You never leave a negative symbol in the denominator. You can write it out front, either bring it to the top, or write it in front of your expression. And here again, we're going to assume that no denominator is equal to 0. All right, let's just practice a couple more of these. All right, write this problem down. Here again, that's x squared. As you're writing it down, kind of look through it, see if anything is not in standard form, because that needs to be rewritten in standard form. All right, step number 1, we're going to factor everything. All right, so let's factor that x cubed minus 8. Here's practice factoring. That's the difference of cubes. So we're going to use our sum sat pattern again. So factor that, x cubed minus 8. So x minus 2, x squared plus 2x plus 4 over, all right, look at this first term. It's not in standard form, so I need to rewrite that in standard form. So that means a negative 1 is going to get factored out. X minus 5, and then that x minus 2 is already a binomial. It's already factored. But if you don't factor out the negative 1, you're not going to be able to cancel. So you need to make sure you're factoring out, or rewriting standard form and factoring out those negative lead coefficient if needed. All right, let's do the second fraction. The numerator. Let's factor that second numerator. So what multiplies to give me negative 5 and has a difference of negative 4? So factor that. So x minus 5, x plus 1 over. All right, second denominator. What multiplies it to give me 4 but adds to give me 2? Well, nothing, so I can't factor it, so it stays as x squared plus 2x plus 4. All right, so now we can cross out like factors. If you need to, rewrite them and group them together. You don't need to, but like I said, if that helps you visually. So x minus 2 over x minus 2. My trinomial, x squared plus 2x plus 4. And then x minus 5, x minus 5. All right, write what's left. So what we have left is x plus 1 over negative 1. All right, let's simplify that because we don't leave a negative in the denominator. So we're going to break it up. So my final answer is negative x minus 1. Alright, let's try a division one. In a division problem, remember just like when you did this with numbers back in elementary school, when you divide fractions, you're going to flip the second one and multiply. So that's what my little dude there is doing. He's reminding you to flip that second fraction. Alright, I usually do it first so that way I don't forget to flip it before I start messing with the problem at all. Before I start factoring anything or simplifying anything, I'm going to flip that second fraction. So let's do that. Let's flip that second fraction. So go ahead and write the problem down. Here again, that's y squared, z squared on the denominator. I'm going to get rid of our little flippy dude. Alright, you're only flipping the second fraction. The first fraction stays like it is. So let's rewrite. So 4xy over 3z squared times 3z to the third over x to the third y squared. Alright, these are all monomials. So let's simplify the numerator. Let's see, we've got 4xy over 3z squared times 27z to the third over x cubed y squared. Alright, let's put them together. Let's make one fraction. So 4 times 27 is 108. X, y, z to the third over the denominator is 3 x to the third y squared z squared. Alright, and finally let's simplify. 3 goes into 108 36 times. Alright, my x's. It's bottom heavy, so when I subtract, my x squared is going to stay on the bottom. Here again, my y is bottom heavy, so when I subtract, my y is going to stay on the bottom. And my z is top heavy, so when I subtract, my z to the first is going to stay in the numerator. Here again, we're going to assume that none of our denominators are equal to 0. Alright, let's look at another one. Same basic principle. Alright, take a moment, write these problems down. Here again, those are x squareds. Look like z's, that particular font. Alright, before I start doing anything, I'm going to flip that second fraction. So I'm going to just rewrite the first fraction. Here again, you can start factoring at this point if you'd like. Just be careful. Like I said, our problems are getting longer, therefore we have more opportunities to make careless mistakes. So flip that second fraction. Alright, everything gets factored. Factored completely, so 2x leaves me with x minus 4 over what multiplies to give you 4 but adds to give you negative 5. So x minus 4, x minus 1. Alright, numerator, let's factor that. So what multiplies to give you negative 4 but adds to give you 3. So take a moment, factor that. So x plus 4, x minus 1. And my denominator, there's nothing I can do to that. Alright, let's rewrite this as a single fraction. So let's see, on the top, I've got 2x, x minus 4, x plus 4 over x minus 1. On the bottom, we typically put the coefficients and monomial things out front. So 4x squared, x minus 4, x minus 1. Alright, now I can start crossing out like binomials. So my x minus 4 and my x minus 1. Alright, let's look at these terms now. These in here. We've got to simplify those. Alright, so our final answer. Alright, 2/4 reduces to 1/2. I don't need to write the 1, so I'm going to put the 2 on the bottom. X over x squared, I'm working on this now. X over x squared is going to leave me with an x in the denominator because it's bottom heavy. All right, everything else is gone from the numerator except my x plus 4. All right, here again, resist the temptation. You cannot divide this 2 into this 4. Mathematically, it doesn't work. You try it with numbers and see that it doesn't work. So there's my final answer. Here again, none of my denominators can equal 0. Okay, so there's multiplying and dividing, probably the easiest section in this particular unit. Here again, you don't have to have common denominators. You're going to factor everything. And please don't fall for the math no-no.